video, I would like to show you on how to conduct factor analysis by using SPSS. But before that, let me show you the background of the dataset that will be used for this analysis. Okay, this dataset will be used to determine benefits from toothpaste. Responses were obtained on 6 variables, which are V1 until V6. We have V1, is it important to buy toothpaste to prevent cavities? V2, I like a toothpaste that gives shiny teeth. V3, a toothpaste should strengthen your gums. V4, I prefer a toothpaste that freshens breath. V6, prevention of tooth decay is not important. And finally, V6, the most important consideration is attractive teeth. So the responses were on a 7 scale point, which is 1 for strongly disagree and 7 for strongly agree. Basically, these are the data set. So let's go to SPSS. You need to open your SPSS in order for you to conduct the factor analysis. So in this SPSS, I have respondent here, 30 respondent, and then I have all the variables V1 until V6 that I mentioned just now. So let's go and analyze this data. First thing to do is to go to Analyze and then go to Dimension Reduction. In this dimension reduction, choose Factor. So you are going to get this interface. So you have your respondent and also V1 until V6. Let's choose V1 until V6 and put it inside your variable box. As you can see here on your right side, we have descriptive, extraction, rotation, scores, and options. Let's explore it one by one. So let's go to descriptive. Okay, in this descriptive, we need to check the initial solution and then coefficient and also CAMO and Bartlett test of sphericity. Then click continue. Choose extraction. Okay, we have few methods for extraction, but the most commonly used is principal component. So we are going to use this principal component, and then make sure we click on correlation matrix, unrotated factor solution, and also scree plot, and then continue. For rotation, okay, there are few methods listed here. Okay, let's try and use Varimax. Okay, this is the most commonly used rotation methods. And then click continue. For score, let's have a look at the score. Okay, we do not have to, okay, we have to click on display factor score coefficient matrix and then click continue. And finally, let's have a look at the option. Okay, make sure it excludes cases listwise and then continue. Okay, after we have done that, now let's click OK and have a look at the output. Okay, these are the output of the analysis that we have done by using SPSS just now. Okay, based on this output, you can have a look at the correlation matrix, the CAMO Bartlett test, commonalities, total variant explained, the scree plot, component matrix, rotated component matrix, and so on. Okay, the first thing to check is your correlation matrix. So based on this correlation matrix, you can see that we have the diagonal values which equal to 1. And then we can have a look at the value on the bottom here are all greater than 0.3. So it is an acceptable correlations. After we have checked the correlation matrix, let's move to CAMO and Bartlett test. Okay, for this CAMO, Kaiser-Meyer-Olkin measure of sampling adequacy, we need to have a value greater than 0.6. So this 0.6 means it has average acceptable value, means it is an indicator for us to proceed with the factor analysis. But before that, we have to check our Bartlett test of sphericity. Okay, for this Bartlett test of sphericity, we need to check either this metric is an identity metric or not. So when we check the significant value, it is significant, means that this metric is not an identity metric. So they have some relationship between the variables. When we fulfill these two criteria, so we can proceed with our factor analysis. So factor analysis is appropriate for this data set. After that, we can have a look at our script plot. Okay, the script plot is actually a graph of the eigenvalues against all the factors. This script plot helps you to determining how many factors to retain. We have to look at the point of interest where the curve starts to flatten. For this case, okay, we have three factors which has, the factor 3, okay, when you have a look at this script plot, we have factor 1, 2, 3, 4, 5, and 6. But as we can see here, factor 3 has an eigenvalue less than 1. So we are not going to consider those factors. So we are going to select these two factors. Okay, this is the guideline given by script plot, but this is only a guideline, so we have to check other criteria, then only we can come up with a decision on how many factors that we want to retain. After that, we can have a look at the total variance explained. Okay, this factor total variance explained actually a factor extractable from the analysis along with their eigenvalues and percentage of variance contributed to each factor that are what listed in this table. Okay, so based on this table, we can see that the first two factors and component explain relatively high amount of variance, as you can see here, whereas subsequent factors only explain small amount of variance. So this one tally with what we have seen in our script plot. Okay. After that, we can have a look at the commonalities value. Commonalities is the proportion of each variable's variance that can be explained by the factors. So we have before and after commonalities value. Okay, before is before the extraction. So before all value are equal to 1 means that all variances are common. While for the value after extraction, we can say that 92.6% of variance associated with factor 1 is common or shared variant. So after extraction, some factors are discarded and some information may be lost. Okay, after we have looked at the commonalities, we can move to factor rotation. So from this table, we have component matrix table and rotated component matrix table. In our component matrix, we have loading for each variable onto each factor. Most variable loaded in one factor while other do not have a clear output. Okay, so we can see here the values of the loading for each factor. To clarify things considerably, we use rotated component matrix output. From this output, it's actually minimize the complexity of the factor loading to make structures simpler to interpret, and also we can arrive at a solution with best simpler structure. So based on this output that we have a look at just now, we can identify two factors for this data set. Okay, so there are two factors that can be extracted from this data set. The first factor consists of V1, V3, and V5. Okay, we can see here. Okay, this one, the values are higher than factor 2. So V1 belong to factor 1. Same goes to V2. V2 belong to factor 2. V3 belong to factor 1. While V4 belong to factor 2. V5 belong to factor 1. V6 belong to factor 2. So as the conclusion, we can say that factor 1 consists of V1, V3 and V5, and factor 2 belong to V2, V4 and V6. Finally, you can give a proper name to your factor 1 and factor 2. That are all factor analysis is all about, and how to do this factor analysis by using SPSS. Hope that this video will help you. Thank you.